So good morning, everybody. I want to welcome you to the Learn, Apply, Create session for our virtual open house here at McMaster Engineering. So my name is Colin McDonald. I'm going to be facilitating this session, and the purpose here is to give you a little bit of an introduction and an overview on your first year experience here at McMaster Engineering, and specifically one of our new courses, Engineer 1P13. So I'm an assistant professor in mechanical engineering, and I'm also the associate director for the iBiomed program. And I'm one of the co-instructors that teach in the first year. So as an incoming student, you're going to get a chance to meet me, and hopefully we're going to interact quite a bit because I'm one of the co-instructors for our first year course. And so this course is one of a number of courses that students in first year engineering take. So the first year program in some ways is similar to a lot of common engineering programs where you get your suite of courses in math and sciences. You get chemistry, math, and physics. And my son has just walked in the door. Buddy, you got to get out of here, okay? Say hi to everybody in the presentation. There's hundreds of people there. Okay, can you go, please? Hi. Thank you very much. And close the door. Somebody didn't get the memo that I'm giving a presentation. That's my son, Alex, by the way. He's 7, and he likes Transformers. And he's in grade 2, he says. So as part of your first year experience, as I mentioned, you're going to get a healthy dose of chemistry, math, and physics. But a big portion of your first year is going to be a brand new experience, which actually launched for the first time last year, is a new course called Engineer 1P13. So 1P13, which is what we call it for short, is a full year course that introduces students to a range of fundamentals in engineering. And so these are the kind of broad topics that you're often going to see in any engineering program, where you learn about computing, you learn about materials and material science, you learn about engineering design, and you learn about the engineering profession, what it means to be an engineer. And rather than introduce you to these topics individually through isolated courses, we bring them together and we introduce them all as one suite, as one single course throughout the entire year. And the objective here is that you as students throughout the year learn to develop technical and professional skills. And you do that through a series of design projects. And these are the design projects that actually blend these topics, where you learn about computing, you learn about materials, you learn about design, and you all do it through these different design projects. Now, the general structure of the course, again, it's a full year course, so it will happen in both the fall term and the winter term, is that you have 2 lectures a week, and those lectures add up to about 3 hours, and they take place in not a traditional lecture hall. Instead, they take place in a large classroom that actually offers a lot of collaboration. So rather than students sitting in a tiered lecture hall, staring at one individual like myself, they're actually at tables where they have lots of opportunity to collaborate. You're also going to apply the material that we introduced to you in lecture, and you're going to apply it through labs. And you have 2 labs a week. Each of those labs is 3 hours. And those labs introduce you to, they cover topics in computing. They cover topics in graphics design. So you learn how to create parts and assemblies of different objects. You learn, there's labs where you're introduced to principles of material science, and it's all through hands-on interactive demonstrations. And you also learn about communication and through various workshops, how to write a report, how to put together a presentation. and all that fun stuff. Okay. So you taking what we give you in lectures, applying it in labs, and everything comes together where you create your own solution to address a design challenge. And we do that through what we call design studios. And these design studios happen once a week where you work in teams to solve an individual challenge. Now, before I touch on the next slide here, I invite you to complete a poll, which is going to show up in just a minute. And that poll is one question. How do you feel about group projects? And there's three answers that are available to you. So please take a minute to fill it out. Do you love them? Do you think that they're okay? Or are there something that, maybe aren't your favorite thing in the world? So please take a minute to fill that out now. And so, as I was saying, is that all of these topics that are covered in this course, you apply them through a series of design projects. And so these design projects happen throughout the year. The projects are anywhere from 2 weeks in length to as long as 6 weeks in length. And they cover a breadth of disciplines, from autonomous vehicles, where you actually learn to control an autonomous robot, to renewable technology, where you learn about wind turbines and designing turbine blades for different environments and different scenarios. You learn about tackling problems in healthcare and utilizing telepresence and robotics to address real world problems. We deal with projects in sustainability, and then lastly, we deal with projects that are focused in community. And the way that these projects are set up is that early on, the projects are designed in such a way that we call them they're well scaffolded. And so everyone's kind of doing the same thing. It's your first introduction to a post-secondary environment. And we give you a lot of the tools that you kind of need to work through a particular problem. And as we get through the year, these projects become more ambiguous. They become more open-ended. And it allows you to tailor your experience based on your own personal interests. So if I can get the results here in just a second. Okay, so we're gonna come back to that. So it looks like I'm gonna circle back here. Looking at the poll, the majority, which is actually quite nice, 53.6% of you said that you love them and that you enjoy working with new people. 43% says, well, it depends on who's in the group. And only 3.6% of you said that it's not your favorite. So that's actually great. That's actually really great to see. I think, and honestly, if you love them, this course is for you. McMaster Engineering is for you. If you think it really does depend on who's in your group, this course is for you. Okay. And if it's not your favorite, this course is for you. Because one of the things that we do a little bit differently is that we don't just put you in groups and we expect you to complete a task. We actually build that team-based experience into the course, and we actually give you the skills to navigate those challenging environments. Because it really does. When you're working in a team, it's true. It really does depend on who is in your particular project group. So in terms of the 1P13 experience, so I've kind of covered and I've touched a little bit on the high level overview of the course. but what's the 1P13 experience like? So as I mentioned, is we cover fundamentals through lectures and labs. So lectures are, you're looking at large classrooms where we'll have anywhere between 200 to 300 students in a room. And so that would be facilitated by one of our course instructors like myself. But it's a highly engaging environment, lots of in-class activities where you have opportunities to engage with your colleagues and your friends, and you get asked questions to myself, but questions to your friends as well. And you also learn those fundamentals in labs. And the labs are a much more hands-on interactive environment. So rather than having 300 students in the room, we have anywhere between 20 and 40 students in the room. And there's lots of support. You've got a number of teaching assistants. You have a number of co-op students who work with us full time, and they're there to kind of reinforce the topics that are covered in lecture. And as I mentioned, the topics that we cover in class blend from materials to computing to engineering design. So if we were to look at one example, which is computing, so here you learn to write programs to effectively solve problems. And there's no prior experience required here. You learn to write programs that perform simple calculations. You write programs that repeat simple tasks, that count things. We call these loops. That's the common computing term for that. You write programs that evaluate, right? Should I do this or should I do that? Should I turn the light on? Should I turn the light off? Should I put my winter tires on? Can I afford to wait for a couple weeks? And you write programs that read data because in the world we live in, there's lots and lots of data out there. It's important to be able to read that and work with it. And so how we actually do this is we start off with showing you how to write a simple computer program. Now, this is a computer program that I would have written back when I was in first year, many years ago, and it's none of your darn business how many years ago that is. So this is an example of a simple computer script that is meant to simulate picking up blocks. And so there's 9 blocks in a stack, and the blocks are yellow, and they're blue, and they're pink. And I need to pick up those blocks one at a time. And I pick them up, and then I place them somewhere else. And then I keep a counter, right? I keep track of how many blocks I've picked up and how many blocks I've placed. And then when the program is done, when it counts through, it ends and it terminates. And it's cool if you're into that kind of thing. And some of you are, but maybe some of you aren't. And the computing can be a big barrier because it can be really hard to appreciate and get excited by the kind of things that a computer program is capable of when we start you right at the ground level. So for some people, something like this is really interesting. For others, maybe not so much. So we up the game a little bit, and we let you take exactly what you did in that lab, and then we let you apply it to a real scenario. So rather than write a simple script, which you still do, that script is then, instead of printing a bunch of statements on a screen, it controls a robot. So we have about 30 of these robotic arms. We call them the Q arm. It's a 6 degree of freedom arm that students are able to control with a simple device called a Raspberry Pi. And so they are able to write commands just like the commands that I had on the last slide. But through those commands, they're able to control that robot. They can move it to a 3D coordinate in space, or they can control individual joints. But it's done in such a way that anybody can do it. And anybody is able to write out these commands to control this robotic arm. And that is part of the experience right through the entire year. Whereas we introduce you to these basic fundamentals, but then we let you explore. And rather than give you an assignment where you need to complete follow step one, step two, step three, we give you a bit of a sandbox where you can play around. And so this is an example of a little assignment that some students did in lab. They actually just did it this week. We actually never told them to do this. This is something that they did on their own. They did themselves. The assignment that we laid out for the students is they just need to pick up these little foam blocks and place them at another spot on the mat. And the students on their own came up with this cool little challenge where they would actually stack them and pick them up from a stack and then place them up from a stack. And they did this themselves. They did this without any help from us. And it really lets them kind of untether, and it really lets them explore and do their own thing, make it their own experience. So students learn the fundamentals of computing, of materials, of design. They have an opportunity to apply it in a lab. And then lastly, we really open the floodgates and we let the students create their own solutions. So we give them a design challenge, and the students are able to, through software that we give them, through hardware that we give them access to, they are allowed to actually create their own solutions to address a particular need. And this is an example of a project in sustainability where students are tasked with picking up different containers based on their material and putting them in the appropriate bin, so that they can be recycled or that they can be thrown in a waste bin. And this is all something that happens within the first year. And students have access to the hardware. Students have access to the hardware in our design studio spaces, but they have access to these virtual environments right from their own laptop. So whether they are in the design studio or whether they are in a residence or whether they are at home, they can access this equipment from anywhere. And really the focus of this project, of these projects, the focus of the entire course is that we want to expose students to design challenges that are both technical in focus, but are also more human-centered. And so I showed you, I've gone through a few examples of some of the more technical projects that students get to do, where they get experience with autonomous vehicle design. They get experience with controlling robotic arms to pick up and transfer medical containers. They get exposure to the design of a large system for sorting and recycling containers. And all of these projects are intended in a way to help develop certain technical skills, but we also introduce students to real world challenges, challenges that are embedded in community. And so through these challenges, we actually bring in members of the community, members of the Hamilton community here and around McMaster, where we invite these community members. We call them our clients, and we do not give students a problem. Instead, our community members share a story. They share their story. And through sharing their story with our students then ask questions. And these questions are asked in such a way to better understand who these individuals are, right? Who are these community members? What are their needs? right? What are some of the issues that they have in their daily life? And taking that information, students are then tasked with identifying a solution that addresses the need of a member in the community. And a project like this does two things. For one, it makes it real, right? It makes it real because now the students are coming up with a design solution for somebody, right? It's meant to actually address a real need, and a need where there is not a clear solution at the end. But it also allows the students to tailor their own learning experience. Whereas an earlier project, there may be an expectation that the students need to use a particular type of software, or they may be expected to use a 3D printer to fabricate a certain device. With our final project in the course, the students are allowed, they're given the freedom to take all of the skills that they've learned and developed and applied throughout the year, and they can create their own experience. Students that are interested in software, there may be an opportunity for a software-based solution. There may be an opportunity for an electronics-based solution. Maybe the solution lies in a simple mechanical device. Maybe it's a simple artifact, and something rather elegant that's going to meet the needs of their client. So it really becomes the student's own learning experience. And what we see from this approach is that everybody comes into this course with the same prior knowledge, but all of our students create their own experiences. And it really makes for a more meaningful, and it makes for a more impactful experience at the end. So I've talked a little bit about, some of these technical skills that students come in with. Um, but at the heart of Engineer 1P13 are the professional skills that we give you, that we help you develop. The one at the top, and the one that I think is probably the biggest, because it's really how the entire course is intended to be run. It's teamwork, right? Is that Engineer 1P13 is all about teamwork. Why? Because life is all about teamwork. It's all about working in teams, working together to come up with the best viable product at the end. The course is about communication, which is not just about preparing a presentation or writing a report. It's about communicating with others, whether it be professors, whether it be TAs, whether it be each other, your fellow students, whether it be members of the McMaster community, whether it be members of the outside external community. We have a number of workshops in technical writing where, again, you learn to put together a PowerPoint presentation. You learn to navigate and access certain tools in software such as Microsoft Word and Microsoft Excel. You learn to reflect, and reflection is a wonderful tool, because nothing happens without reflection, right? Is reflection is all about is all about stopping and asking, okay, what did I do? Why does it matter? What am I going to do next? It's about time management. It's all about taking these tasks, balancing your workload, and coming up with effective strategies that's going to set the pathway for success in your future career. It's also about building a portfolio. As part of 1P13, we help you craft a portfolio that speaks to who you are. Build a portfolio that fits side by side with your own resume, but at the same time, it stands apart because it highlights some of your qualities. It provides a visual, it provides a little bit of media to tell us a little bit about who you are. What do you need coming in? Nothing. Nothing beyond the requirements that are what you need to be accepted into McMaster Engineering, which are basically the high school courses in if you're coming from an Ontario university in English, calculus, chemistry, and physics. This is really the prior knowledge that you need. Everything else, do you have computing experience? Great. Do you not have any prior computing experience? Perfectly fine. We assume that you don't have anything. We start from the ground up, and then you learn the skills as you go along. And we have a gigantic support system of 8 instructors, of 12 co-op students who are working full-time, 100 teaching assistants who are there with you the whole way. And so that's all for this session. Any questions I'm happy to take that pop up in the chat. And I do want to thank you. I want to thank you for your time, for coming to spend time in this session. And thank you very much. Any other questions that pop into the chat, I'm happy to take them now. And yes, Lindsay, thank you very much. If you have any other information that you want to learn about McMaster Engineering or specifically about 1P13, you can navigate to that link in the chat. And I must say, it is an absolute miracle of having 3 children under the age of 8 in the house and only 1 burst through the door. I would call that a win. Thank you. Thank you very much, Brent. Alrighty, so that's pretty much all for me. Thanks again, everybody. I hope you have a wonderful weekend. It's a beautiful weekend here in Hamilton. A little cool, but the sun is out, which is awesome. And I hope to see you very soon. Hope to see you next September right here. Well, not here in my home office, but just down the road over at McMaster. So have a wonderful day, everybody. I hope you enjoy the rest of your sessions here today, and take care. Bye-bye.